This is our final project midterm presentation on the topic of flight delays from the perspective of weather-related delays. This presentation will include a brief description of our project structure and goals, details of the data processing we've done so far from the perspective of our data cleaning, questions we've investigated thus far, and visualizations of their conclusions graphically, how we have modeled our data, and where we are currently at in our project and how we plan to move forward. Right now, we'll talk a little bit about the project overall. For our final project, we are interested in examining the correlation between flight delays and weather. So far, we've worked with 3 datasets. One containing information on United States flight delays in the recent years, another detailing recent weather events, and a third as a tool to merge the 2 previously mentioned sets. We are interested in analyzing our merged data to identify delay causes and how weather-related variables such as type and severity may contribute to delay frequency and duration. Our goal is to use the discoveries resulting from this project to offer solutions to minimize flight delays and improve flight efficiency. We also hope to provide evidence to some more lighthearted theories about which airlines are most notorious for delays and which airports should be avoided if you'd like to get where you're going on time. Now we'll discuss our data cleaning process. We began our project with 2 very large data sets, each with several million data points, and what you can see here on this slide in the cloud diagrams is the differing attributes of each data set. In the next slide, we'll talk a little bit how we used these attributes to merge the data sets. To merge weather and airports, we mapped ICAO to IATA airport codes. And to merge flights and weather, we merged on the origin IATA airport codes and dates, as well as destination IATA airport codes and dates. We chose to fully clean the data set after it had been merged since we needed some of the attributes to complete the merging. So what you can see on this slide is the attributes that we had dropped from the data set after the merge occurred. We'll now discuss how we used the clean data to examine points of interest within our project with graphical visualizations. The next 2 slides show bar graphs made with the Matplot library examining arrival and departure delays by city. We first grouped the data by the flight city of origin and took the average of the departure delays from that particular city over the entire data set. We then plotted the results of the 15 cities with the highest average departure delay. On this slide, you can see the bar graph with the y-axis being the city of origin and the x-axis being the average delay time in terms of minutes. We performed the same process here, with the only difference being that we're plotting the destination city against the average delay to receive delay by arrival city. On this slide, we plotted the airline code by departure delay by first grouping data points by airline carrier and then taking the average of the departure delay duration with regards to each airline. We repeated the same process here for arrival delays. Now we'll discuss how we've modeled our data thus far and how we plan to continue modeling it in the future of our project. This is the result of applying dbScan to a sample of 10,000 data points within our dataset. Unfortunately, this data model didn't yield the results we had hoped for, as many of the data points or flights within the dataset are labeled as outliers, and most are within very similar clusters. However, we can still gain some useful information from this model. We can see that most points are localized towards the left corner of the graph, meaning that within this sample, delay duration isn't incredibly large. Additionally, we can see that the points are highly correlated in a positive linear fashion, meaning arrival delays and departure delays are proportional to each other. If nothing else, this helps us validate our data as reputable, since these trends are representative of what we'd expect and experience in the real world. However, in the future, we hope to model our data more successfully using regression to predict delay duration by severity of weather, as well as using an interactive map to show flight delays by airport and/or city with a weather overlay over a sampled period of time. Here is our progress update. So far, the focus of our project has been cleaning our data, merging our main data sets, using graphical evidence to begin investigating larger questions within our project, modeling our data, and brainstorming, researching, and debugging data modeling methods we believe will be useful in the overall goal of our project. In the future of our project, we will continue investigating questions by building graphical evidence and work on implementing more sophisticated data modeling techniques, such as regression and our interactive map, to retrieve strong evidence to draw conclusions upon and provide solutions from. For a better look at our data and progress, you can refer to our project GitHub at the link below.
Thank you.